What's up, math fans? I'm going to talk fast because I have a lot of vocabulary I need to go through. I want to talk about the different types of functions, and a function is really just a relationship between x and y. So instead of calling it y, we call it a function of x. All right? I know you know what x is. X is the first variable. It's the independent variable. It's the input. It's the domain. Any one of those is fine. And usually we put integers in for our domain. Integers for our domain. Integers for our domain. So integers are whole numbers, counting numbers. They can even be negative numbers. They're just not decimals or fractions because we're lazy and we don't want to work with decimals or fractions. But you should understand you can easily put decimals and fractions in as well, unless it's a word problem. So if a question says, hey, what is the domain of this word problem? You have to imagine what you're talking about. So let's say my x is cars and my y is number of right turns. If I own one car, I make 4 right turns in a day. If I own 2 cars, I make 7 right turns in a day. Whatever. And then they ask you, well, what's the domain here? Well, I can only own 1 car or 2 cars or 3 cars. There would be no point in putting negative numbers. I don't want to own negative cars. There would be no point in putting fractions. You can't own a fraction of a car. If it's a straight math problem, absolutely fractions go in your domain. But if it's a real world problem, just the integers. So you got to be careful what we're talking about. So for right now, no word problem, just numbers. So I want to know what my function is. A function is a relationship. So what is the relationship between x and y, or the f of x? What is the relationship? Well, I think I taught you a trick already. You just want to see if it's, let's see if it's linear. Your choices are linear, quadratic, exponential, or absolute value. Those are the main relationships. There's also cubic, and it gets crazy, but let's start with that. So is it linear? If it's linear, there is a constant rate of change. Find your rate of change by using the slope formula or the shortcut trick that I taught you, which is to see, look, 1, 2, 3, 4, it's going in order, so let's see if this goes in order. What is the change from the first term to the second, from 4 to 7? Let's say this is a sequence of numbers. They use that word also. If this is a sequence of numbers and the first term is 4, what's the second term in the sequence? 7. Next term is 10. Well, let's see. What is that change? Looks like the difference is 3. So I'm adding 3 here. And then, ooh, I add 3 again. And then, ooh, I add 3 again. There is a constant rate of change, so it's linear. Could you tell me the fifth term? What's the 5th term in this sequence? 4, 7, 10, 13. It's got to be adding 3 again, so it's got to be 16. All right, if you're ever not sure, you can pause the tape and rewind if I'm talking too fast. Please know the vocabulary, but get some graph paper and plot these points, 1, 4. 1, 2, 3, 4. 1, 4 is here, 2, 7 is here, 3, 10 is here, 4, 13 is here, 5, 16 is here. My rise, I rise 3, I run 1, rise 3, run 1. If you get a straight edge and connect the dots, guess what happens? Straight line. Obviously, it should continue forever in both directions because it wasn't a word problem, so it can go on to negatives and positives forever. It's a straight line, therefore this guy is linear. Linear. Okay, my function is linear. That's the first type of function, linear. That was easy. You're already linear masters, so we're going to get rid of that. Let's explore if it's not linear. Let's look here. Oh no, I gave away the secret. Well, first of all, they would ask you, is this linear? And you would say, this is going in order, so that's good. Let's see. From here to here is plus 1. From here to here is plus 1. From here to here, minus 1. From here to here is minus 1. From here to here is minus 1. From here to here is minus 1. Looks linear, we're good. Let me just verify. From here to here, that's where I was looking earlier, is plus 1. From here to here is plus 1. It's not linear anymore. It was linear up to here. When my domain was negative, it was linear. When my domain is positive, it's linear. But the whole thing, not linear. So what is this called when part is linear and then the other part is linear? Plot these points and see what it looks like. All right, I'll wait. You done? Great. It should. 0, 0 is right there. Negative 3, 3 is here. Negative 2, 2. Negative 1, 1. 0, 0. 1, 1. 2, 2. 3, 3. It should look like a beautiful V, hypothetically, goes on forever in both directions. And this is your second function called an absolute value function. Notice I'm allowed to connect the dots because I'm allowed to assume that there are fractions in between. Just because I didn't put the fractions here, goes on forever, fractions in between, okay? This is my absolute value function. What is this third one? There is no way it's gonna fit on paper, but I'll give you a hint. If you watch my videos, you know that I used this before. It comes from a movie. 0, 1 is here. 1, 3 is above it, and 2, 9 is far above it, and 3, 27 is far, far above it, and then by the time you get to 481, you're way off the thing there. So when it rises quickly like that, it actually creates a kind of curve, and that is considered exponential, all right? And I'm gonna exclude quadratic, because quadratic also rises quickly, but not as quickly. So we're gonna explore the difference between quadratic and exponential in the future. So this one is exponential. That's an exponential function. So you should be comfortable with at least seeing 3 types of functions. Linear, what's this one? Absolute value, and exponential. Those 3 for now, okay? Just looking at it, you should know which one you're looking at. One's a curve, one's a V, one's a straight line. I want to make a quick connection to scatter plots. Scatter plot, they might give you 100 points. See, I only gave you like 5 or 6. Scatter plots might give you 100 points. And you sit there and you plot 100 points. And it comes out something like this. That's not a perfect straight line, but it does go up. So it's not linear, but it's kind of linear. It is actually a correlation here. Correlation is also like a relationship. If the numbers get bigger on your x-axis and the numbers kind of also get bigger, not perfectly, but they generally rise on the y-axis, that's a positive correlation. Positive correlation. Even though it's not a perfect line, it's a positive correlation. And in a future video, I'll show you how to figure out the best line to draw through those points, because you should not sit there connecting the dots making a shaky line. This is called the line best fit. Positive correlation, dots are going up, line best fit's going up. Guess what a negative correlation looks like? It's going to be dots all crazy because it's a scatter plot, but in general they come down, which is a negative correlation, and the line best fit would look like this. No correlation means the dots are all over the place and you're not quite sure if I should draw a line going up or down. It's too scattered. That would be no correlation. Correlation means there's some kind of relationship. X goes up, Y goes up, or X goes down, Y goes down. I'm sorry, X goes up. X is always going up if I'm going this way from left to right, but possibly Y is going down when I drew my line going down. So as X is going up, Y is going up, that's a positive correlation. As X is going up or Y is going down, that's a negative correlation. As X is going up but you don't know what's going on with Y, that's no correlation. Don't confuse that with causation. Causation comes from the word cause. Something causes something else, cause and effect. Does the X cause the Y? You might say yes, but you have to explore the word problem. It usually comes from a word problem. Just because I own a car, does that cause me to smoke cigarettes? No. So just because I own, the more cars I own, the more cigarettes I smoke, you might see the dots going upward and say, oh, that's a positive correlation. But did the cars really cause me to smoke? You cannot make that conclusion, so you can't say it has a causation. You have to be clear on what the word problem is, all right? Just wanted you to be familiar with the vocabulary and the 3 types of functions. Thanks for watching. See ya.